What's cooler than a petabyte of data? Using that data to improve your customer business, your own business, and even the world. Hello, I'm Felipe Hoffa, a Google Cloud Developer Advocate, and today I'm in Toronto, Canada, to meet my good friends at Geotab. They are the world's largest provider of telematics, tracking more than 1 million vehicles on the 7 continents. And we're going to meet Fiona Zhao, their senior data scientist, who is going to show us how they manage all of this data and even how you can use it to understand how the world moves around your house. So let's get started. Join me. We're here with Fiona Zhao, Senior Data Scientist at Geotab. Hi, Fiona.
Hi, Philip. Very welcome to Toronto.
I'm so happy to be here. So what does Geotab do?
So Geotab is a telematics company. We provide open platform fleet management solution to business of all kinds and all sizes. So we're now having over 20,000 customers with us. And those customers are using the Geotab devices to connect their vehicles to their business so they can manage and monitor the productivity, the efficiency, the safety, and the compliance of the drivers and the vehicles. So we're now having over 1 million devices in running vehicles. And from those vehicles, we're collecting over 2.1 billion data sets per day.
So what does the device look like?
This is Geotab Go device. You can see it's a small box, beautiful, and there's a whole bunch of magic happening inside the box, collecting the data. It's actually very easy install. You can just plug and play.
Even I can plug it?
Yeah, we have a harness already installed on the truck, and the only thing you need to do is just plug the device in, and after a few seconds, you will hear beep, and now it starts to work.
Oh, now it's sending data to your platform?
That's right.
And how does this data get into the platform?
Once the device filtering and the calibration of the data, the device itself will just ensure that we are sending the data that carries the most information with the least network cost. So I believe within several seconds, the device data will go into customers' databases as well as our big data environment for analysis.
You are a data scientist. What's your job as a data scientist?
One part of my job is playing with those data. I'm very happy to have this large volume of data to work with. From them, I can create a whole bunch of analysis from different angles to help the internal users to diagnose any possible potential risks or flaws or bugs. And on the other hand, I also work as a big data engineer. So as an engineer, I need to ensure that I design and develop a reliable system.
So you have to create the pipelines, store the data securely,
Yes.
and make the analysis possible for everyone.
Yeah, and as business grow, I need to make sure my application survive for that long time and also grow, can adapt to the future change.
So you scale this platform as it grows more complex, it collects more data, more people are interested in looking at it. How long ago did you start?
I started in Geotab in 2014.
2014, like
Yes,
4 years ago.
Yeah.
Exactly. In 2014, you chose BigQuery
Yes.
because you were able to finally put all of this data together
Yeah,
in one
we were
place.
actually growing with BigQuery. We tested with several cloud providers, and then we met with Google BigQuery. And we were very happy with the performance of the BigQuery API and also the capability of BigQuery to run very big queries based on large scale of data. We were quite happy with that, and we stay with BigQuery.
So how does Geotab look like now?
So we're having 2.1 billion data points per day.
Per day? That's
yeah,
a
when
lot
I
of
joined
points.
in 2014, there were around 300 million data per day, so it's almost 6 times of growth. Geotab encourage other team also to push their data to monitor their work in BigQuery. So right now, if you go into Geotab office, you will be surrounded by the dashboards and monitors and where the whole company is using data to monitor the work, and we're a data-driven company essentially.
Can you show me one of these dashboards?
Yes.
Oh, cool.
Yeah. As I mentioned, we're using these dashboards to see how much data are coming and how quickly they're coming into BigQuery.
Wait a second. This dashboard is a Google slide?
Yes, and it's a live dashboard. It will be refreshed every 5 minutes.
Wow.
Yeah.
And what can you see here?
So from the top, you can see the total number of records we're in BigQuery right now is over like 1 petabyte. And
More than a petabyte.
right. And just for today, we got over 2.1 billion rows already.
Wow.
Compared to the records a year ago, it's almost double. And from these gauges, you can see like per second, we are having over 16,000 of GPS records. And GPS records is less than 1/3 of our total data points.
So this device is not only recording the GPS position.
So GPS position is just 1/3 of it. We also get all kinds of the engine diagnostic data from the vehicle engine computer, such as whether the driver is buckled is the seatbelt, and also the fuel consumption. Whether there is any like diagnostic signal come out from the computer, all kind of things, and also the temperature.
Also temperature, so you're tracking all of the insides of the truck thanks to your connection.
Yes, yes.
And then this data comes out from the device into your platform, into BigQuery.
Right.
And you're tracking the time that it takes to do all of this.
Yes, so it's only 7 seconds.
7 seconds from device to BigQuery.
Right.
And you have a chart of the latency.
We're monitoring the performance from our servers.
So tell me more about the slides. That's really interesting.
Yeah, so in the background, we're running queries. The data are in BigQuery. We use the Jupyter Notebook, which is hosted by Google Data Lab. We write queries in the notebook, produce all these pictures and gauges. We push up these guys onto Google Cloud Storage, and this Google slide can pull those files from Google Cloud Storage and produce this beautiful dashboard. And jobs are setting, and the Google slides can actually refresh itself every 5 minutes.
That's a really creative usage of slides. And then to orchestrate all of these queries?
Oh, yes, because queries have dependencies. And we are using the Apache Airflow to orchestrate those dependencies. And it's easy for us to know is there anything going on with either of the dependencies.
So BigQuery, slides, Airflow, what else?
Also, we're doing machine learning projects. Yeah, so we're using TensorFlow as a framework. We deploy our applications and pipelines onto Google Dataflow and also the Kubernetes clusters.
Can you show me one of your current projects?
Yes, it will be very exciting to show you one of our websites we just launched. It's called data.geotab.com. Geotab see the value in big data, and we want to show that those value of big data can definitely empower business, because we are not just about telematics, and telematics is not just about GPS and position. We have the engine diagnostic from the vehicle's engine computer. We have all kinds of other data that comes from the auxiliary. So Geotab can actually provide an open platform, so business can use those data and even marry with other data sources they have to create creative tools or reports or any intelligence out of those data. So as a start point, we produce a set of intelligence data set to help people, to show people, okay, these are the cool things that we can do with the data.
Aggregating data within multiple customers.
Yes, within multiple customers, because we want to make sure there's no any privacy issues, confidentiality issues, and the customer need or the users need to worry about their data.
And we can see what's happening within cities.
That's right. either the government or the people can leverage this data to do some solutions for the smart city even. So for example, we analyze what are the areas with high risk of incidents.
So you're empowering smart cities, governments, and drivers to see where are the dangerous areas. Can I see the website?
Yes, of course.
Nice.
Let me show you. Data.geotab.com. Within the website, you can find the data solutions, which is the one that I mentioned, that we create some intelligence data set as a starting point. We have three categories of those reports. One is weather. So you believe it or not, the vehicles are actually collecting the temperature and the barometer pressure. We can use this data to report real-time and hyperlocal temperatures.
You're getting hyperlocal weather from all of these trucks, vehicles all around the world?
Yeah, we're at a granularity which the regular weather station might not be able to. We also have the urban infrastructure, like the high-risk driving areas are one of them. The third category is the location analytics. So for example, where are the most popular gas stations and what are the gas station types? Maybe some of the gas stations are exclusively for truck, others are for passenger car. So we have those data and can help users to locate their proper gas station. And also about the parking lots, you can interestingly say what are the circle for parking.
So show me a little more about the urban infrastructure. What kind of data you are collecting
there?
Yeah,
there is actually one data set that I produce, which is the hazardous driving area. As I mentioned, we're collecting accelerometer data. So our former engineers calibrate and clean those data. And we also have a whole bunch of talented engineers to do lots of experiments within a real car. The purpose for that is we need to find a threshold of the acceleration so that we can detect, okay, right now the driver is doing harsh brake or harsh heading or harsh cornering.
And now you're counting the number of incidents?
Yes, and also as we know that the bigger the city is, the more the incidents will potentially be. So we count the traffic flow within that area and use that to normalize the incident count. And then we come up with a score, measure what's the level of risk.
Can we take a look at the data?
Yes. So as a user, you can actually use your email address to register into this website. And then within maybe several minutes, you will get a response email and just follow the instructions. You can get into our system to get the data.
So anyone that registers and agrees to the license of this data can take a look at it and find what are the most dangerous areas.
That's right.
And how would a query look?
In the white paper on the website, it had introduction to what does this data set do and how people can use this data set to produce a whole bunch of insights. We listed several examples here. As the first example, we're looking at the cities prone to hazardous driving in Ontario, Canada.
But I live in California. What if I wanted to see what are the most hazardous areas in California?
That would be interesting. So right now, suppose I'm already in the BigQuery dataset.
You already have permission to look at this table. And what are the results?
Yeah, within 7 seconds we get the results. And you can see, I'll move the laptop a little bit. The top cities is Los Angeles.
Because it's one of the biggest cities too.
Yes.
Followed by Long Beach, San Francisco, San Diego, Oakland. And if we wanted to find the points that were the most dangerous, how would you do that?
The points, okay. If you want to look at Los Angeles, we can search for Los Angeles.
This query is going over how much data?
This data set itself is not very big. It's several megabytes of scale.
So the size of this data is not impressive. These tables are about 10 megabytes. But what's impressive is how much data you use to produce them.
Right. In order to produce this small table, we actually run analysis based of at least 1 year of GPS and 1 year of acceleration. and maybe other data sets as we need. So in the background, there will be like over 50 terabytes of data are supporting this report.
So you're able to do everything within BigQuery. You can analyze those 50 terabytes, publish the new tables, and make these tables available for anyone that wants to access it.
That's right. So here the columns, we have the average latitude and average longitude. This is the location of, it's the average location of the incidents happening within a scope of area. And the size of the area is around 150 meter by 150 meter.
150 meter squares approximately.
Yes, and it will also give the boundary point of this square. We give 4 points, the 4 point, and also the city, county if it's in the state, and the state or province name, country name, ISO country code, the severity score that I mentioned. We come up with those measurements, and the incident total number of incidents.
Exactly. So you have one count. The first row has in this case, has the area with the maximum severity score.
Yes, that's right. And we also break down the incidents by vehicle types, such as like passenger car, hot truck, on the road truck, or on the road vehicle, or off the road vehicle like tractors, construction vehicles, or electrical vehicles, and even like natural gas vehicles. But in the other columns, we are capturing all kinds of vehicles data.
Nice. So you are able to see how traffic conditions vary depending on the type of.
Yes, and people may be also interested in what type of vehicles are collecting them, are creating the most incidents on certain areas, so they can help their analysis based off more granular data.
Yeah. And then on the first row you have the most hazardous one, and the second row we have one that has had more incidents.
Yes.
Yeah, and if we wanted to look at that point, how would you?
You want to look at the second one?
Yeah.
Let's copy the incident position and open Google Map.
And with the Street View, we can jump into the exact place.
So if we zoom in a little bit, we can. It looks like around distribution center or construction area, which like the driveway to the traffic without any traffic light control.
Can you show me a little more about that? Like what's happening behind the scenes to produce these tables?
As I mentioned, we use Notebook to write queries and explore the results, and actually running the query jobs. So first we need to like calculate the traffic flow. To normalize the data, we need to count the incident from the raw accelerometer data comes from the device. And also a very important step is we remove all the differential information from this data, and then we aggregate and we set up the jobs running in the background month by month and day by day to collecting data and run those reports.
And that's how you end up with a query like this one?
Yeah, we're able to actually leverage the power from BigQuery. We can write like the user-defined functions, UDFs, to set a customized date that we want to look at, because these queries are running as job. We cannot manually set a date, so we use UDF to get what's today's date. And with these grammars, subqueries, we can make these queries look beautiful and easy to manage.
And then for each geohash, for each hour, you're getting the...
Yes, and we're able to use such as array aggregation function so that we can easily combination and manipulate data easily.
How much data would this query go through?
This query, so for 1 day of GPS, we'll probably have over 15 terabytes.
15 terabytes.
And yes, and these queries can just finish within minutes.
Within minutes.
Yeah, it's really amazing.
Yeah, well, it powers everything you're doing, so it's really good. And that's how you are able to handle complexity. You put this within Airflow.
Yes, that's right. There are lots of such queries running in the background, and we manage it in a diagram, dependency diagram in the Airflow, so we can monitor them.
And what are the plans for the future?
So definitely more intelligence data set gonna come out.
More intelligent data, nice.
And also, as you said, these jobs are batch jobs.
Yeah.
We run the analysis based on historical data, and in the future, right now I'm working on the streaming analytics. So we're hoping in the near future we can really see the city map in the real-time fashion. Say, for example, you're gonna say what's the traffic flow now on the roads, across the road.
So you will be able to produce streaming analytics with data flow?
With data flow, yes, Apache Beam and Kubernetes.
And also
Yeah, and also my coworkers are working on a machine learning project to learn the driving patterns of the fleet. And once we know it, we can help the users to compare the fleets. They can kind of benchmark their work to improve the productivity, the efficiency, also the safety and compliance.
Yeah, so with machine learning, you will be able to extract more knowledge, produce actionable advice, improve the safety, improve the productivity.
Yes, we expand our insights. Like we always did it, we did it well, but with machine learning and the big data, we're gonna have the capability to do it with more deeper insights.
Yeah, Fiona, I'm really impressed how you went from like this device to disparate databases to join all of this data in one place, how the platform has grown in the last 4 years. It's impressive.
Yes.
I'm so glad you wanted to share this data and analysis with me.
Yeah, right, because Geotab is believing in management by measurement, and we want to help other businesses to do the same thing. And it's we're make decisions driven by data, and we're gonna help people to do it too.
That's really awesome. So thank you for joining us. And everyone, well, you can follow me at Felipe Hoffa and keep tuned for more data videos. Stay curious.